Since we already learned about the EDA analysis and how do we draw some of the different kind of the regions, whether they have the peak value or they have the very less frequent of the values with the number of the casualties. Then look on the modeling perspective. How does the UK road accident time series forecasting is needs to be helpful to predict the future accidents? So the major agenda for this project is able to understand ability to drag some of the interesting results with future data sets and future analysis so that we will able to try to figure out the way to build that model by using the different kind of the time series models. So we're going to be arrive the solution with respect to the 2-year accident data set into the future based availability of the data. So in this project, we're going to be experiment with the different kind of the models such as the LSTM, long short term memory, and also neural networks, along with the GRU, gated recurrent new units, and also the bidirectional LSTM, and along with the conventional LSTM. So let's play around with these kind of the different models so that we will enhance the results with much better and try to conclude the results at the end. So let's get started. We already seen about the data sets and what exactly the data set consisting of and the different kind of the file formats we had. I'm just skipping those kind of the cells so that we will able to understand the data much better. So I'm also importing the Python and also the heavy profit libraries. If you don't have any kind of the requirement satisfied, you can directly install Excel remote with the PIP install. So let's also import a couple of the libraries which going to be useful to plot and also figure out the way we are going to be necessary for the deep learning prospective models and with the Keras and also the TensorFlow. So yeah, let's go and discuss with respect to the modeling plot with corresponding the data sets what we had. As you can see, they are derived for the 27 data sets and also the 2011 and also the 2014, which is going to be concatenated with corresponding to these values. So in this step, we're going to be concatenated these data sets so that we will able to get the UK accident data sets fully. So as we already seen, there are few of the missing values, and let's also tune those missing values whoever having the greater than 10,000 results for the null values. And along with whoever having the more than 1 lakh record, we need to be tuned by using the none of the values, and we can also drop them. So we can also convert different kind of the data filters to extract with the date, year, and also the month, year, and also the month, so that eventually get some of the descriptive analysis with corresponding to this we already seen in the in that videos. So let's play around with the SARIMA model with respect to the forecast UK accident based on the number of the casualties. Just extract with respect to the date and also the number of casualties so that we will get the data set with only the two different columns. So I'm just doing the aggregating number of the casualties for the each day of occurrences so that we will able to get the data with corresponding to the average value for that. So this is the with respect to the occurrences for the each and every day data. So we can eventually validate using this data to plot or maybe figure out the way what we want to do some kind of the modeling with the SARIMA. So as we progress, we already know about the Go library. So Go is the one of the good library to plot any kind of the plot with respect to the x-axis and also the y-axis. So let's say I have taken the x-axis as a date with corresponding to the range between the 2006 year to 2014. So we're going to be seeing the monthly average results with corresponding to the accident rates. So this is the accident rate with corresponding to the monthly average for the each and every year. So we can also see the plot. How does that going to figure out the way, the number of cases, casualties. As we clearly observed about the 26th data is slightly somewhat decreased and also the increase the wave. So it is not a stationary kind of the stuff, but we can conclude this might be a somewhat the stationary at the period from the 2005 to 2008 or maybe 7. Yeah, 2007. So in this case, we can also see one drastic observation with recording the 2008 data. We don't have any such kind of the data or how does it going to be happen. We can drill down these two and further action. And you can also see the with corresponding to 2009 to 2011, 12, and also 13, 14, 15 having the huge difference with corresponding to the 2007 to 2014. At the time it was went to 2013, it is very drastically decreased, but suddenly it may be happened, the somewhat the correlation may be happened with corresponding to the number of accidents are very high. So what exactly that 2000 have, it have does not have the data set, since it's going to be very missing. Let's interpolate with corresponding to the different kind of the method. So currently I'm just using the quadratic. So quadrant is going to be very helpful at the time of interpolation or interpolation with corresponding with get the more consistent data. So drill down to the 2000 net data in the different kind of the format, so that interpolations may be varied the times of the quadratic or maybe the cubic or maybe the spline. So yeah, we're going to be expect the same results if you apply directly also cubic and also the spline. So let's also try that, okay, so that you will able to get the different kind of thought with similarities. So I'm just using linear, so that we will also get to understand about what exactly the results with corresponding to 2008. So I'm just drawing those data sets with to get the mean values and the test and also the train data set. So let's try out the SARIMA model, which we are already talking about. So SARIMA is basically we already seen in the previous classes, which basically does with corresponding to fitting of the time series data to get to help and also the understanding better whenever we don't do prediction with the forecasting mode, forecasting the values we based on the current values. So the season may be the component of the ARIMA. So we in this term only we can see the seasonality with the ARIMA term, accountability to the seasonality of the time series data. That needs to be defined as a seasonality as we progress in this way. It might be a seasonality way of somewhat the stationary, but not completely satisfied with the stationary values, but it may be having the stationary kind of thing. So seasonality is automated process, what you already know, and ARIMA components, which we had as the AR and also the moving average results. So we can integrate with corresponding to that and to get the seasonality with the ARIMA model, then we should call it as a SARIMA model. So let's try with a different kind of the order of the autoregressive. So we can take the p value and also the q value for the different laggings, so that we will eventually get the lagging forecasting errors, so that we needs to be get good identity of the stationary of the time series data, and also some of the pattern to check the time series data is going to be splitted with the base level or maybe the trend level or the seasonality level, or with some kind of the occurrences of the error. So at the time we are going to be make some kind of the changes also, we need to be understood about p value and also the q value. So currently we're going to be used for the multiplicative combination for the base level and along with the trend and also the seasonality index along with the residual to check about the time series data sets, the patterns in our data set. So a multiplicative way of the decomposition is also assumed to be format components and also the component combinations of the multiplications. So let's see multiplicative decomposition. How does that going to be work? We already seen this in the previous classes. So if you are not fully accumulated with whatever the terms we are just teaching about multiplicative decomposition, please go and watch those videos so that you will able to understand the way what exactly that these terms and how does this going to be impact with the model building. I am just taking the seasonal decomposition, so that eventually take the combination with corresponding the each and every value with the whatever the trend we are going to be face. So let's see how does the trend and seasonality and also the residual error we're going to be seeing. So as we can observe, this is the somewhat the seasonality to make sense, and the trend wise it is very decreased the way whatever we had, and the date multiplicative decomposition is also very low whenever we have in the 2008. That's one of the major reason may not be having the data. So in above plot, we can see the composition diagram. The time series is going to be exhibiting as a repeated seasonal patterns. So with corresponding to this, we can also see the trend is very down from the 2005 to 2008. So the 2012 also somewhat maybe slightly higher, but the results showed maybe having the not that much of the huge spike, maybe the somewhat the narrowed spike. So we can also check about the augmented Dickey fully test. In the ADF test, we're going to be see the testing results of the null hypothesis going to be indicated for the time series pauses of the unit root, which is the non-stationary. So if the p-value is going to be arrived from the ADH test is less than significant of the 0.05 typically, right? So we're going to be reject those kind of the hypothesis testing. So if not, then we're going to differentiate the data and it make that as a stationary. So let's perform the ADF test. So ADF test is going to be arrived for the minus 3.34 and the p-value we're going to be have 0.01. So which is very less than when compared to the 0.01. So based on this ADS stage 2005 to 2014 data set is in the non-stationary. Since the p-value is also greater than the 0.0y, it requires some of the differentiate and also make it some kind of the stationary results. So we're also going to be get the d value. So for that, we just use the grid search or maybe the random search to for the hyperparameter tuning for the SARIMA model. So just for the understanding, we're going to be used for the grid search to get to know about those. So we can also plot the autocorrelation function and partial correlation function to get to determine the auto retracement, also the moving average. So those of you don't know about the autocorrelation function, which you already discussed in the previous classes, I'm just going to be adding some of the results to conclude with corresponding the SARIMA model what we had. So autocorrelation function does with the coefficient of the correlation between the two different values in the time series is called as autocorrelation function. So at the time we're going to be get autocorrelation function, it needs to be measured as a linear relationship between the observations at the point of t and also the observation point of the previous times. So same as a result of the partial autocorrelation also, but the small difference is we going to be we cannot be correlation is not going to be expected with corresponding the mutual correlation with the specified set of the other variables. So the partial correlation may be happen between the y-axis to the x-axis with the amount of the correlation. Maybe they that going to be happen with the common correlation with the x-axis and also the y-axis. So what exactly this does is sometimes it's going to be very effective for the moving average terms. That's the reason we are taking instead of that. So ACV also plays very important role for the moving average, and we can try and error with corresponding to the grid search whatever we had. So let's play around with ACF and also the auto regressive models with the p value and also the q value. So autocorrelation or partial autocorrelation will going to be have the different kind of the lag results. So in this lag results, we are going to be see the first four lag results are more significant line when compared to the all the other. So in the SARIMA model, we used to go for we needed these four kind of the lag results, and since we already know about appropriate of the partial autocorrelations, which may not be included with grid search for the SARIMA model. So let's perform the grid search and to get to know about the p value and d value and also the q value. So, so I'm just taking the values corresponding the range we are going to be set for the q for the 4 and the maximum for the p2. So we're going to be give these kind of the values at the end, and so that we will going to be trained by using the SARIMA models. So and also these are the some of the frequency of the series and the model determinant d and the set of some seasonality may be the true in we are going to be now data sets on the seasonality. So these are the summation of the minimizing the ASA values with corresponding to the different kind of the P, Q, D values. So the best model for the P is best model for the P is a 0 and Q is a 1 and D is equal to 0. So let's perform this evaluation with corresponding to the different kind of the results what we had. So in these results, we are going to be seen with corresponding the values for whatever the correlation matrix what we had. Just around the values, SARIMA has 0, SARIMA max has 0 to 1 and cross of 0, 1 and 1 comma 2 and also the 1 2. So what exactly the AAC is? So low AAC is nothing but which needs to be tells about widely used for the measurement the statistical method, which basically tells about the goddess of the fate and along with the simplicity of the model into some statistics nature. So let's perform some of the diagnosis steps with corresponding the model to check if the linear or not. So the model needs to be linear, some sense within the from the theoretical context. So QQ plot will be shows and this is the linear format, and also the diagram which shows as a somewhat the Gaussian distribution, and also the KD plot. Assumption of the linear regressive model, we already seen some of the assumptions we're going to be seeing. If you're not aware of these kind of the linear regression assumptions, please go and check out the previous video so that you will able to see what exactly the assumptions of the linear regressions. And also we can plot for the forecasting results for the test data sets. We can implement this into different kind of the future values to predict. So red line is indicated as the predicted forecasting for the monthly accident rate, and for the blue line, it's basically indicating the actual average monthly accident rate. So by using these plot, we're going to be arrive at the solution which may be having this much of the confident interval with corresponding to this kind of the area to get the more number of the accidents when compared to the less actual predicted accident rates. So let's also try with the evaluation matrix with corresponding to the ME value and also the mean absolute error. So we can drive the solution with corresponding to the different kind of the plotting mechanisms. So I'm also taking with the max of the 4 and also the max of the 2 for the Q, and let's corresponding to with the frequency the series D, and the seasonality is the true. So let's try with this data sets and also the different kind of the P and Q values. So now here you can see correlation matrix we had drawn, and let's try with the 24 period so that future 2 years of the values, the next accident rates. So I'm just drawing this on the plot which shows like this. So with regarding whatever the values up to 2014, whatever we have, then we can go and get the 2016 values like this. So it may be tying up with these kind of the values, may not be tying up with these kind of values, but we can arrive the solutions at the end by using the seasonality, by using the monthly average results. Let's also try with SARIMA model with the time gap, the data sets we have, the results, that is the AAC value will be better when compared to whatever we had. So I'm just taking from the 2019, so 2009 data sets onwards, so that we can control the solution instead of taking from the 2005. So yeah, let's fix this one, because what happened, this is not a somewhat the stationary data sets. We are not coming across whatever the values we are going to become. So let's fix, and still it is still not stationary. Let's do some kind of the transformation technique so that it needs to be identified with the stationary values. As you can see, correlation is somewhat very less whatever we have already seen. Only first and second lags have the above significance values. Other than that, we don't have any kind of the significant values for the partial correlations also. Only the 1 2 have the significant value, first and second lag. So always we needs to be perform the grid search. That is the best practice, I would say. And also p value needs to be 3 maximum of the p value, and also the q value maximum of the q is 3 also. Set the stationary, and along with the difference is 0. So let's try it with this approach. Then we can control the results for the different kind of the linear format or not. So you can see here the histogram clearly tells about it needs to be checked with the linear format with corresponding to whatever the results we have get by using the p equal to 3 and also the q equal to 3. So let's perform the forecast results on top of these test data sets from 2009. So it varies, you can see it varies when compared to whatever we have seen in 2005. Depending on the forecasting accident rate might be having the non-stationary results. So depending on the stationary results, whatever we have concluded from 2015, right? So let's also play around with the accident rate after 2 years, and maybe the average accident drop for the each year. So the major results we are going to be get till now is accident rate is going to be set for the 9.7 percentage with regarding this, and average number of the casualties due to the road accident for the each year is 65, well less than the previous year. So if you, I mean, we already covered the FB profit. If you are more comfortable with the FB profit, let's also try with the FB profit. Then we can go for the LSTM, bi-directional LSTM, and also the GRE, so that we will able to identify, if not time series analysis. SARIMA model may not be good results to have with it don't have the non-stationary data sets. So FB profit is also one of the good library from the Facebook. So let's play around with these kind of the approach, and then we can conclude with the results in the end. Yeah, those of you don't know about the FE Prophet. FE Prophet is one of the open source library from the Facebook, which is based on the decomposition trend and seasonality along with the holidays models. So these trend, seasonality, holidays, and error terms needs to be concatenated together, and we're going to be get as a good results and ahead for the forecasting results need to be applied for the multiplicative results. So just checking with training error for the DS. So DS is used for the nomenclature with corresponding the IP profit we had as an input and Y is the output for the. So just take that consideration and do for the multiplicative seasonality mode. Then we can gather the solution with corresponding whatever the values we had. So predict the values and corresponding to that we can plot the results at the end. So these are some of the values we're going to plot, but you can see these kind of the results is going to be it for the predictions of those values. 26 in the data sets, and the mean absolute value is also very less, and percentage is very less, but the error is very high when compared to the. And let's also see the trend and seasonality. How does that going to happen? This complete data sets from 2014 onwards. So trend is somewhat slightly decreasing along with March values also, March, May, and January values. The yearly is increasing trend, monthly wise is decreasing. Let's also focus more on the 2 years into the futures by using the FB profit. So in this case also it needs to be changed drastically monthly wise from whatever the values we are going to be predicted. So let's have a look on this diagram. In the 2016 is varies, but in the SARIMA model it does not have that much of sense to understand, but in the forecasting results with the FB profit is more detailed way of approach whatever we are going to be expected, same as like the previous year the one we had. Same patterns we are going to be able to see in the FB profit also. So number of casualties are very less when compared to that, and the number of casualties with corresponding to the values that drop in nature in the previous year. And let's also focus more on the LSTM. LSTM also does the same operation with the modeling so that we can able to predict those kind of the values in the future 2016 onwards. So let's get started with the LSTM. So these are all the splitting and the data preprocessing steps which needs to be happened. Data scalar, standardized scalar needs to be happened because it needs to be validate the results at the end with corresponding to whatever the values we are going to be arrived for the prediction point of view. So these are all we have already seen. I'm just skipping those whatever the cells we have already seen. So forecasting these results, and let's look about the parameters. The LSTM parameter which were just drawn for the learning rate is very less, 0.001. Learning rate is 0.0001, which is very less, and also the we are taking optimizer for ADAM so that we will eventually optimizing the solution much better and also the computation efficiency. And let's also include some of the dropouts and trial and error method with corresponding to whatever the mechanisms we are going to be showcase. If you want to be add more number of the layers also, that should be fine with the return sequence is equal to one with the false. So let's play around with corresponding whatever the mechanisms you followed. I followed this kind of approach. It may not be helpful. So that's the reason I commented, and I commented these kind of results. So yeah, the total number of parameters are somewhat less. So let's train by using these parameters since we don't have that much of computation efficiency. And along with extend and also the vice trend, we are just splitting the test set into the cross validation split for the 10 percentage. So let's see how does the error needs to be happened with corresponding the train and also the cross validation. So the orange line is indicated as a validation data set. The more number of the heap ups are increasing, we're going to be get as a very less. So at the end of 55th or maybe the 57, we are going to be approach with corresponding these values. So let's predict with this by using this EPOP and try to train the LSTM model so that we get the forecasting results at the end. Though these are some of the forecasting results with corresponding to whatever the mechanisms we had, but it is not fully fitted with corresponding whatever we have already seen. So the number of casualties, the number of road accidents are very varying with corresponding. The probably maybe the small size of the data set. That's one of the reasons. So calculate the MAP and MA value, which is somewhat higher, whatever we have seen, that is the 0.9% at the time, which is very higher. So it is not working properly for the LSTM to hyperparameter even. And let's go for the gated recurrent units, the GRU one. This is slightly extension with this LSTM, so as you already know. If you are not, you can check out the previous videos so that you will able to identify this. Same pattern we are going to be applying here, Adam optimizer and also the learning rate 0.001. So we use as GRU instead of the LSTMs with the different kind of the layers. So play around with this high number of the total parameters. So let's plot with corresponding the number of the hip hop, which is very high. Computation efficiency for the hip hops are 200 is very high. So let's figure out the way what exactly we needs to be happen at the end for the forecasting results. It is slightly better whatever the computation efficiency. It maybe take some time to compute this one, and along with you're going to be get as very good data set. Again, this is a small data set, that's a data for what we actually expected. So MA value is slightly low when compared to whatever we seen in the LSTM 20 for the MAE value. Let's also fix this in terms of the bidirectional LSTM. Those who don't know about the bidirectional LSTM is, so which is just the complications of the one forward and also the backward recurrent component, which this basically tells about the both back and also the forward information with corresponding to the sequence at the each and every timestamps. So let's try out the bidirectional LSTM, whatever the mechanisms or the layers we are going to follow with, and the total number of parameters are very less when compared to whatever we seen in the LSTM. So here also computation efficiency is very high when compared to the train and also the validation results. So let's perform with the forecasting results with the actual scores. Yeah, which is also very good, but slightly not satisfied for the best fitting model. So since we already optimized this kind of the bidirectional LSTM method or model to do much of the better because of the small data sets only. So error is also very very high. What exactly we have drawn the conclusions. So conclusions about the LSTMs may not be works for the small data sets. That is the basic capturing underlying the pattern. So what exactly we have already seen for the FV profit and also the SARIMA models. So let's also try with conventional LSTM. So which is also one of the best LSTM we're going to be seen for the time series, universal time series forecasting. So time steps we're going to be take for the four extend and also the white and text and also the white test, splitting into the different kind of the timestamps. So here we are going to be take the timestamps into two subsequences and also the columns are two and along with the rows are one and also the features are one. So let's play around with the conventional LSTM so that we will going to be get at the end for the different kind of the parameters to showcase for the number of the EPUBs are slightly low when compared to whatever we have already seen. So let's play around with the predictions of the model. So which is very good when whatever we have already seen, but not that much of SARIMA and also the profit. Those kind of the MA values are very less when compared to what we have. So overall, the numerical calculations also trial and error mechanisms with different kind of the approaches or the architectures. So we couldn't figure out the optimization of the LSTM forecast for these kind of the data sets due to small data set, unfortunately. So this may be happened small size of the data sets having the 120 rows after aggregating to the all the months. So we're going to be seeing maybe in the future we're going to be get as a more data for this kind of the Hook accident results or Hook accident time series forecasting. It couldn't be generalized the data for the test one, so we cannot figure out the way it's going to be productionized and much better to predict the future values. Thank you.